Welcome to Task 8, which is solving for systems of linear equations. And I think this falls into Chapter 6, but we're going to go ahead and cover it now because it's part of the water park. So we have solving for systems. What this means is we are basically looking for where the lines intersect. So remember, in relationship to the four quadrants, that if you're only looking at a line segment from one location to another, you need to consider it in terms of that line segment actually can extend endlessly in either direction of those points. So if the line segments we are looking at are in different quadrants, we need to remember that eventually, if we extend them out and we're walking along that path or driving along it, that eventually they're going to have a point where they meet. That's what we're actually looking for with this task. So if you look at task 8 on your thing, it says that you are going to select two lines, preferably two that actually do cross on your blueprint, and use the substitution method. Oops, got a little carried away with that. That should just be an N. To solve for the intersection point. You're going to mark each intersection using a yellow point. I would suggest a marker at this point, even as much as I hate it. The yellow point there on your blueprint. All right. You will do this for 3 intersecting lines on the actual assignment that you're turning in. I'm going to ask that you do 5 total before you choose the 3 that you and your teammates are going to submit. You know what? I'm actually going to say 1 per teammate now that I remember the way that it is loaded into Google Docs. So 1 per teammate. So with exception to the group of 2, you're going to do 2 each. All right, so I'm probably going to go ahead and make sure that we do several examples so that, because this is one of the things you need to know about. The one that the paper gives is that y is equal to 2x plus 14. That equation is a slope-intercept equation. And that should be easily recognized by you from the previous task 7. So what it basically is saying is you are going to take 2 of the slope-intercept equations. And again, I highly suggest that you look at the map first and identify 2 lines that cross on the map and use those. Or you don't have to. That's up to you. I suggest it, but that's just me. All right, so the first one they give is y is equal to 2x plus 14. These y's and x's are represented by ordered pairs. The 2 is the slope, and the 14 is where it crosses the y-intercept, because that would have been in the form of y is equal to mx plus b. The second equation that they have given you as an example is that y is equal to 3x minus 7. And I'll make a memo to myself later to go in and change those values of x and y for ordered pairs, the font, so they're not capitals, because they really shouldn't be for this. And again, this is still in the format of y is equal to mx plus b, slope-intercept form. Now what this is saying is that we have one equation that is set to what y equals. And we have another equation that is set to what y equals. So essentially, both of those equations equal y. With that said, they both equal y. If you remember where we had the graphing on the number line, and you had and ors, and where they overlapped or they were equivalent to the value, it's kind of that same concept. If this is saying it is equal to y, and this is saying it is equal to y, they're saying you can set them equal to each other. Because if we wrote it like this, we could say that 2x plus 14 is equal to y, but then y is also equal to 3x minus 7. So let's save ourselves some messiness, and let's just do away with the y and do away with the second equal sign. And now we just have 2x plus 14 is equal to 3x minus 7. What that means then is through the process of balancing equations and properties of equality, we can actually solve for x by combining like terms, remembering that this is a positive 14, this is a negative 7, and this is a positive coefficient of 3 being multiplied by the variable of x, and this is a positive 2 being multiplied by the variable of x. So what we have to do is we have to move what's not attached to the variables first. So I'm going to go ahead and subtract the negative 14 here, minus 14, and do it to both sides. Please make sure you indicate that this is equal to this by putting this line underneath it. Some of you are real bad to leave that out. Go ahead and bring the 2x down because it has not been touched. It is still intact, but 14 minus 14 is 0. Go ahead and bring the 3x, the coefficient of 3, and the variable down of x because those two have been left alone as well. And now we have a negative 7 and a negative 14. And so that's adding two negatives for a value of negative 21. This is on one side of the equation. Now we need to leave it there and we need to move this to the other side of the equation. And that can be done by subtracting 3x from this expression here. And I think in the example, I actually left a negative sign off, which I'm going to go back and fix for you. Some of you might have caught that when you looked at the example, and carry that back down. It's actually a negative 2x in that first negative 2 of a coefficient. All right, so then if I subtract the 3x from a positive 3x, that becomes a value of 0. It's missing. So this side of the expression now has a negative 21. And then we have a negative 2 and a negative 3 for a value of negative 5x. So I'm going to scoot this over to, now just carry over on the next page, negative 5x minus 21 equals negative 21, not minus 21. Wow, okay. This means that I can use the division property of equality on each side. This is the same thing as a negative 5 being divided by a negative 5 for a value of 1, positive 1. 1x is equal to, ew, that's not neat. Gotta go ahead and show the division process. So 4, 21, 4 times that, 21 and 5th. I would then rewrite that as x is equal to 4 and 1/5. Some of you may ask, can I write it as a decimal? That's fine as well. This one is a really neat numerator over denominator. If it's not, then you can go ahead and write it as a decimal. This of course would be the 4.2. Either of those are acceptable answers. So all we have done for all of this is find an x value, which is now part of the ordered pair of the x, y points where the two lines will meet. Now we need to do the same process and solve for y. What that means is I can take either of the initial equations that I had, either the y is equal to negative 2x plus 14, or the y is equal to 3x minus 7, one of those, and put this value of x into one of those and solve for y, which will give me the ordered pair y, which will then go into the ordered pair of this point. So far, this ordered pair is 4.2, and now we are going to solve for the y. So let us take y is equal to negative 2 being multiplied by, I'm going to go ahead and leave it as 4.2. And to that we will add 14. And so then I go ahead and multiply this part first. 4.2 times 2, 4, 8, 1, negative 8.4 plus 14. And this will give us our y value. And 14.0, annex it because this is in the tenths place, and this is a negative 8.4. So now I need to treat it just like you would treat normal subtraction using decimals. So we have a y value of 5.6. Decimal wise, obviously fraction wise would be 5 6/10, and 6/10 would then be simplified to 3/5. So if I want to go ahead and then take this value and place it into the y value of the ordered pair here, that now tells me that if I go on the map for those two lines and find that point on where those two lines hypothetically would meet, these are obviously not lines that are on your map, these are lines that I've made up. If I would go and do that the ordered pair that would accompany them on the x and y axis would match that point. So what I need you to do is before you pick the three you guys are going to submit, go ahead and do one problem of an intersecting of two lines. One problem with two lines that are intersecting that you will solve individually in this notebook. And then check with your teammates. Then you guys will decide on the last, the ones per each team. And you guys will solve each of them. And then you will go ahead and round robin each of those answers. And then you will go ahead and type each of those into the Google Doc.